integrating simulation into Mylan's manufacturing operation. Mylan was originally created as a small pharmaceutical distributor and has grown to be the second largest pharmaceutical manufacturing company in the world. The Morgantown location, where we have focused our efforts, currently produces 18 billion doses per year. To accommodate the different types of drugs that are being manufactured at this location, groupings of products with similar processes called value streams were created. Value Stream 1 has the highest manufacturing output, currently producing nearly a third of the total doses at the Morgantown location. Our group was given the opportunity to initiate the use of simulation software within the Operational Excellence Group at the Mylan Morgantown location. The OE group at this facility focuses their efforts on process improvements. Simulation offers an alternative method of proposing future process changes. Value Stream 1, the project's focused value stream, produces only one drug, which shall be referred to as Product A due to confidentiality. It begins at the first weighing station, which weighs the different components. These components are combined into a batch in the first blend. The first blend also begins to make the chemical mixture more uniform. The batch then moves to fluid bed, where the powder is exposed to moisture to increase the size of the granules. The product moves to third blend, which allows more components to be added to the batch and further breaks down the granules to consistent sizes. The product moves to the grand assay test, where the potency is evaluated taking a sample, during which the batch moves to the second weighing. This process ensures that the batch has had enough of the product to complete the order. During final blend, one of the 13 different color combinations is added to the batch. The final steps involve compressing the material into uniformly sized pills and counting and packaging the product into individual containers. For a majority of these processes, there is a setup and clean time associated with the runtime. We use three methods to collect data. 1. Mylan's SAP system, where employees manually start and stop a clock when working each process step. 2. If raw data was unavailable, we use expert opinions from employees. They would give a minimum, most likely, and maximum process time for setup, run, and clean. And 3. We utilized predetermined Mylan standard times. We realized there is an opportunity for enhanced data collection methods and procedures, which can increase the data accuracy in the future. When analyzing the raw data we receive from the SAP system, we utilize Minitab software. The data analysis process consisted of 3 steps. 1. We imported data into Minitab. 2. We graphed it. 3. We utilized the individual distribution identification function. We graphed the data in a histogram to identify any outliers and to see the underlying potential distribution. We then use Minitab tools to discover the underlying distribution needed to build the model. If unable to find a distribution, we investigated potential outlier points with Mylan and deleted those confirmed points from the dataset. We identified if the distribution was a good fit by comparing p-values of each distribution and choosing the highest value over 0.05. This statistic allows the simulation software to be as accurate as possible when recreating these processes. This chart includes the distribution results from our data analysis. We created the simulation on iGraphics, the software package Mylan is looking to purchase. The simulation is modeled after the previously explained process diagram. There are a few minor differences between the process map and how Product A moves through the model. First, we have removed first weighing from the simulation. Second, a large decision module was added to assign attributes to each batch of Product A. This was done by using a large series of if statements that assigned each batch dependent upon the current color of Product A. Thirdly, we removed the grand assay test, as it does not affect the overall time of the transaction moving through the system. After we completed the model, we attempted to verify and validate. The model was successfully verified as it runs as closely as possible to the actual system. Unfortunately, the model could not be validated, even after attempting to recalibrate using the cycle time. We believe that this is due to the quality of the input data that we have previously discussed. Our deliverables included training in the form of documentation, sessions, and pre-recorded videos. The training guide covered the basics of simulation, detailed analysis procedures, and the iGraphics model creation. Training sessions were provided on-site in Morgantown, as well as web sessions which were recorded for future use. An additional pre-recorded video was included on the basics of iGraphics. The 2 major recommended next steps include continued education on the simulation software for the OE team and improved data collection methods. These 2 recommendations will improve the quality of simulation models created in the future. We would like to thank all of these people for all of their contributions and assistance while making this project possible.